Okay, so let's just jump right in. How much is a life worth? I know it's a question that feels, well, it feels impossible, maybe even a little offensive to ask. But believe it or not, policymakers have to grapple with this every single day. Today, we're going to dive into how they do it, using a really complex and honestly a pretty misunderstood tool that helps make our world and especially our roads a lot safer.
And let's just acknowledge the elephant in the room right from the start. As the OECD themselves put it, this whole idea it's challenging. We all feel it, right? Life is priceless, so putting a number on it just feels cold. But the thing is, this isn't about valuing your life or my life. It's about creating a system, a framework, to make better, more consistent decisions about safety for all of us.
So, if it's so uncomfortable, why on earth do it? Why create this formal process that seems to boil a human life down to a dollar sign? Well, the answer, and this is the really interesting part, is all about what happens when we don't.
See, the thing is, even when we try to avoid putting an explicit number on it, we're making choices that place an implicit value on life all the time. Every single time we, as a society, decide to fund one safety project but not another, or create a new regulation, we're making a trade-off. We're deciding how much we're willing to spend to be safe.
And wow, just look at this slide. This shows you what happens without a consistent method. When researchers looked at different US regulations, the value per life saved was all over the map. I mean, from $100,000 for child-proof lighters all the way up to a mind-boggling $100 billion for solid waste disposal rules. It's just wildly inefficient.
So you can see the problem, right? To make better, more transparent, and frankly, more effective decisions with the limited money we have, policymakers knew they needed some kind of standardized tool, and that's where this whole concept comes into play.
And that tool is the value of a statistical life, or VSL for short. Now, this definition is absolutely crucial, so let's break it down. It is not, I'm going to say it again, not the price tag on an individual person. Think of it like this. It's a measure of how much a huge group of people is willing to pay to reduce their risk of dying by just a tiny, tiny amount. So if 1 million of us are each willing to pay $10 for a safety measure that cuts our risk by 1 in a million, well, that's $10 million. That 10 million is the VSL. It's the value of saving one statistical life from that group.
This table really nails the difference. The value of an individual life, your life, my life, is priceless. It's infinite. That's an ethical, personal idea. The VSL, on the other hand, is a finite number. It's just a statistical tool for policy analysis. It's not about saving a specific person we can point to. It's about the benefit of reducing a tiny risk for millions of anonymous people.
Okay, so you might be wondering, where does this number even come from? Are they just pulling it out of thin air? Nope, not at all. One of the main ways they figure it out is through something called stated preference studies, which, is basically a fancy way of saying they run very detailed surveys. They go out and they just ask us. They ask people how much they'd be willing to pay for something that makes them a little bit safer.
But that leads to another pretty obvious challenge. I mean, how do you get someone to really think about a tiny change in risk? A 5 in 10,000 chance of something happening it's just a really abstract idea for most of us to wrap our heads around. Well, this is how they do it. They use visual aids, just like this one from a real study. They can literally show you a grid of 1,000 squares and say, okay, right now your risk is these 10 black dots. We have a new policy that could get rid of 5 of those dots. How much would you be willing to pay for that? Suddenly, that abstract number becomes something you can actually see and understand.
All right, so the researchers run the surveys, they crunch the numbers, and they come up with a VSL. But now for the million-dollar question, so what? How does this number actually translate into real-world safety improvements, like better guardrails or new traffic lights on our roads?
It all comes down to something called a cost-benefit analysis, or CBA. This is a standard playbook governments use for all sorts of big decisions. It's pretty simple, really. They just add up all the costs of a project and weigh them against all the benefits. And the VSL, well, that's the key ingredient that allows them to put a dollar value on the biggest benefit of all, saving lives.
Let's make this super concrete. Think about putting a new guardrail on a dangerous curve. Step 1, how much does it cost to build and maintain it? Easy enough. Step 2, engineers estimate how many lives that guardrail is likely to save over the next 20 years. Step 3, and this is the magic step, you multiply the number of lives saved by the VSL. That gives you the total benefit in dollars. And finally, step 4, you just compare. Is the benefit bigger than the cost? If the answer is yes, that's a project worth doing.
And we're talking about real numbers here. A huge 2012 report from the OECD looked at dozens and dozens of studies and recommended a base VSL of $3 million for its member countries. Now, keep in mind that's in 2005 dollars, but that's exactly the kind of figure that gets plugged into these real-world cost-benefit equations. But, of course, it gets a little more complicated. It always does, right? That $3 million number is really just a baseline. What research shows is that people tend to value risks differently depending on the context. How much you're willing to pay to reduce a risk from air pollution might not be the same as what you'd pay to reduce a risk from a car crash.
And this chart shows that super clearly. That same big OECD analysis found that when the risk was about the environment, the average VSL was actually higher, around $5.5 million. For general health risks, it was about $5 million. And for traffic risks specifically, it was closer to $3.5 million. So you can see how context really matters in these calculations.
So let's just boil this all down to the most important things to remember. First, and this is the big one, VSL is not the price of a person. It's a tool to put a value on risk reduction. Second, it exists to make our safety spending more consistent and transparent than it would be otherwise. And finally, and this is critical, it's a number that's actually derived from what we, the public, say we're willing to pay for our own safety.
Now, it is absolutely crucial to understand that this tool is not perfect, not by a long shot. Economists and ethicists are debating this stuff constantly. The methods for calculating it are always being refined, and the numbers are always being updated. It is very much a work in progress, our best attempt to bring some rational thinking to an incredibly difficult subject.
Which really leaves us with this final thought. The value of a statistical life is an imperfect tool, for sure. It's trying to measure something that feels, well, immeasurable. But it forces us to ask, what's the alternative? Without a tool like this, how would we make consistent, transparent, and fair decisions about where to spend our limited resources to save the most lives? It's a tough question, but it's the very question that VSL, for all its flaws, is trying to help us answer.